This is the video notes for the section on functions. We already talked about functions, and we also said that for every x value there can be only one y value. That's how we determine a function. But what I want you to think about before we discuss it in class is what kind of situation or scenario would represent a function. Try to think about what could happen in the real world that could represent a function, and maybe even an example of what may not be a function. If you come up with some really good examples, let me know and we can share them in class. The bottom line is just remember that for every value input for x, we can have only one output. So we can only have one y value for every input value of x. In other words, you can have only one range for a given domain. We have four ways to represent a function: verbally, numerically, graphically, and algebraically. And right now I'm going to give you the definitions of these, and we're going to look at some examples of each. We can represent verbally using words like input, output. For numerical, we would use a table or a mapping. An example of that would be your XY T table, or a mapping where we show that our X values, our inputs, go to exactly one Y value or output. Graphically, we could use the Cartesian plane. Here I have an X and a Y axis and an X axis drawn with a parabola. This would be an example of a function graphically. Or algebraically, using an equation like our familiar y equals mx plus b. Another way to think about a function is any function that can be uniquely solved for y. So let's take a look at this equation, y squared minus x plus 1 equals 0. Can we uniquely solve for y in this equation? The first step I'm going to take is to move my x and my 1 to the other side of the equal sign. This gives me y squared equals x minus 1. The next step I need to do to solve for y is to take the square root. Now the problem I have here is that when I take the square root of y squared, I actually get two answers. I get a positive and a negative. Now since I get a positive and a negative answer here, a plus and a minus, this means that it's not uniquely solved for y. That means I don't have just one possible solution. I have two possible solutions. And this squared right here, this y squared, this squared right here should include you in that there are going to be two values for y for this one value for x input. And of course, when that happens, it is not a function. Basically, what we end up with here is a sideways parabola. Now, given that I just explained that, you should be able to tell which of the equations represents y as a function of x. In other words, which one, number 1 or number 2, is a function. If I look at the first equation, I see that I have an x squared plus y equals 1. That means that whatever value I put in here for x, I'm going to square it. I'm still only going to get one value for y. So in this case, number 1 is a function. In example 2, we have negative x plus y squared equals 1. Well, we're going to have only one value we're putting in here for x, but we end up with what? 2 y's. So this is not going to be a function. This will not be a function. Next, let's take a look at function notation. Function notation is something that you need to get very familiar with in Precal because we use function notation now more so than just the letter Y to represent range. So function notation looks like this. We have this F here, which just is the name of the function. It doesn't have any value. It's not a variable. It's just the name of the function. We could call this Fred of X if we wanted to. Okay, it just means that we're going to call this a graph. All right, now this one right here, this X tells us what input we're going to have. This is our X input. Very important to remember that because this is the same X that's on your Cartesian plane for X. So this would be X. This is also X. This X is the same as this X. So this tells you what function does. This function multiplies the input value by 2. So this is my input value. This is 2 times my input value. Now the total f of x, sometimes we often see that written as y. Okay? So don't get confused. All right, so what I want you to realize here is that when you see y equals f of x or f of x equals y, f of x and y are the same thing. The x in f of x tells us what our input was, and then of course f of x is y. So you could actually see a point look like this. X, comma, f of x. This is the same thing as x, comma, y. And it's real important for you to understand this concept because I think this is where a lot of students get confused in Precal. Just remember that f of x is the same thing as y. And this letter right here, f, is just a name. Next, let's look at some examples. We're going to do some substitution. All right, so first of all, I've taken the value 2, which is what they want me to use for an input. I've taken this value 2 and I've substituted it in to my equation. So here I put my g of 2 equals negative 2 squared plus 4 times 2 plus 1. And then what I'm going to do is just simplify this. All right, so I have substituted in my 2. I simplified this. This becomes a 5. And then we end up with the point 2, 5. My input was 2. My output, 5. So I end up with this solution, 2, 5. We can also do this with other variables like t for time. Okay, so we end up with negative t squared plus 4t plus 1. It's the same equation. We've just replaced x with t. We're not going to do this last example in our notes, but if you want to give it a try on your own, it might challenge you a little bit, but if you're up for the challenge, give it a try. On the next page of the notes, we have a piecewise defined function. The graph that's on your notes with these equations don't match. They're not the right graphs. So what we're going to do is we're going to skip this example, and I'm going to go over some examples with you in class of piecewise defined functions. We're going to have almost a whole class period to practice this. All right, so all a piecewise function is it's a function that's been just cut up into pieces. You see this function here starts up, it stops right here, it has an open circle, then it jumps over to here, it has a closed circle, then it goes up, it has an open circle, then it jumps back down here with a closed circle, and then goes down to infinity. So we have some different, it's a function, but it's cut up into pieces, and that's why it's called a piecewise function. We're going to practice with some of these this week in class. But the one thing that we need to be able to do is we need to be able to find the domain and range of a piecewise function. So the thing that we need to remember is, what does an open versus closed circles mean? What do open and closed brackets mean? And what does union mean? Also, we need to understand the relationship between the open and closed circles and greater than or less than, and greater than or equal to, and less than or equal to. So here you can see I've written down some common notation. This one here is the greater than symbol, less than symbol, but it's not equal to. These equate to the open circles on our graphs. This means that I'm going to stop here, but I'm not going to include that point in my solution set. For these endpoints, we're going to use parentheses. Parentheses means that the graph is open at that point. Over here, I've shown the greater than or equal to and the less than or equal to symbol. Those equate to a closed circle on our graph. This would be closed circle, so we're going to include this. It's equal to. So since it's equal to, we're going to include it. And since we're going to include it, we're going to make that a solid point. And when we're writing domain and range, we're going to use brackets to represent the points where we are including that value. So now what I'm going to do is I'm going to write the domain and range. I'm going to write the domain in red, and I'm going to write the range in green. All right, so I've written the domain in red, and I want to just show you how these symbols represent our graph. This right here, open parenthesis, means that my graph is coming in from negative infinity. It's coming in, it doesn't stop here, there's no circle there, so I'm assuming that this is an arrow and it goes on to infinity. So this is coming in from negative infinity and it stops at -1, but that's an open circle. So we have an open circle also at -1. That's going to mean that I'm going to put in my domain, I'm going to write a parenthesis here. Then I have a union. Union means that we're going to include another piece. Each one of these represents a piece of my function. So this is one piece. Here's another piece. I have a line from 1 to 3 for my domain. Starts at 1, includes 1, and goes all the way to 3, but does not include 3. So I have a closed circle at 1, which means I'm going to have a bracket, and I have an open circle at 3, which means I'm going to have a parenthesis. Then union, now I'm going to do my last piece of my graph, that's this piece right here, and it starts at 3, and it's a closed circle, so I'm going to have a closed circle, I'm going to have a bracket, 3, comma, and then of course infinity goes on forever, and that is never closed, so you're always going to have a parenthesis around infinity. You're never going to have a bracket around infinity. You cannot close infinity. All right, so for range, again, we start at negative infinity for range, and we go all the way up to the value for y here is 2, but it's open, so it's not included. Union, now we're going to go from 2 to 6, and this is where range stops. That's the highest point we have for range on our graph. So that's an open circle, but we're not going to include it. So that's also a parenthesis and not a bracket. And here I've illustrated the points that represent these parentheses and this one bracket. So if you notice here, we're coming in from negative infinity. This is one of my y values that's open. This one's closed, and then this one's open. And that's as far as we go with the y values. So open, open, closed, open. That's all we have for now for these notes. We're going to continue practicing in class. Please write down your questions if you have any questions about the notes, or if you have any questions about any of the problems that we're covering in class. If you want some extra explanation, please let me know so we can go over that together.